So good day class. So today we're going to have a short lecture on site investigation, soil mechanics, and excavation and earthworking. So before any design is made, the architect is required to get as much valuable data about site excavation and building erection at the project site in order to determine the character of the materials which will be encountered at the level of a foundation bed. So before you're going to design something class, the first thing that you're going to do as future architects is first to get first the data on what is the soil type that you're going to build upon. Okay? So if the soil is too, if during the soil investigation, the soil is what you call this too loose, and which means that there's some water or it settles easily. So the foundation in design would be different. There are some soil that can handle multi-stories, and there's some soil that can only handle a single story. And it would really affect the design because it would also affect the budget. Because if you plan to build something that is uh, high-rise building on a soil that is not stable, then you're going to have to spend a lot on the foundation. Okay? So that's why it really affects the design. Okay? So the results of the soil investigation. Okay? Then there are two methods of exploration. First is are test pits for shallow work. An open pit is the most suitable method since it calls for an actual inspection of the undisturbed material over a considerable area. Then we have what you call test borings for excavations that are carried no deeper than the proposed level. The underlying material may be investigated by test boring. Okay, so let's move to the next slide. So first, let's understand the classifications of soil. So there are two broad classes. Okay, so these are general classes of soil. A is the coarse grained soil, which consists of relatively large particles visible to the naked eye. Then we have fine grained soil, which is consists of much smaller particles such as silt and clay. Okay, so these are some of the examples of the characteristics of soil. So I will not read everything here. So just take a screenshot and familiarize yourselves with the different symbols and descriptions, as well as its presumptive bearing capacity. Okay, and also its permeability and drainage. Okay, so when you see gravel, there are some of it, if it's clean, it has excellent permeability and drainage. However, it's filled with fines. It has poor permeability and drainage. Then you have sands. Clean sands have excellent permeability and drainage. While sands with fines, it has both fair and poor permeabilities. Then when you say about silt, it has poor and impervious depending on its type. Then you have the clay, which is very impervious. That's poor. Okay, with elastic inorganic silt. Okay. So basically, when you say clay, its permeability should be quite poor. Okay. So just familiarize yourselves with the different presumptive bearing capacities. This data class, I think you will need this when you will be encountering your, what you call this, engineering mathematics or architectural structures when you reach your fourth year or fifth year. So you can already use this data to design the foundation. And then let's go for the different meanings. So allowable bearing capacity means the maximum unit pressure foundation is permitted to impose vertically or laterally on the soil mass. Then density is the critical factoring determining the bearing capacity of granular soils. Then SPT means standard penetration test, which measures the density of granular soils and consistency of some clays. So it records the number of blows required by a hammer to advance a standard soil sampler. Then you have what you call MDD, or maximum dry density. So dry density is the density of the soil or the like after it has been heated at a temperature of 105 degrees Celsius to a dry condition. Then you have shearing strength, which measures the ability to resist displacement when an external force is applied, due largely to the combined effects of cohesion and internal friction. Then you have what you call the water table, which lies beneath the soil saturated with groundwater. So beneath the soil class, see, if there's water flowing through it, that's what you call the water table. Okay, so next slide. So excavating and earthworking entails the following process. So the first is excavating. Okay? So this is the process of digging the earth to provide a place for the foundation of the building. So if you're going to do a large multi-story building class, excuse me, okay, if you're going to do a large multi-story building class, you may need excavators. But if just a two-story building, then you're going to use a much smaller machineries or sometimes only human labor for it. Then we have what you call the leveling and grading, which is the process that change the land elevation and slope by filling in low spots and shaving off high spots. Then the third is stabilizing the soil, which is the process of compacting the soil on which the structure will rest. So after you have leveled it, okay, then you stabilize it, okay, by compacting the soil. Then you have the protection of adjoining structure. It's a law that provides that any person making an excavation is responsible for resulting damage to adjoining property. Okay, so you have to be really careful, class, when you do excavation, especially if there's a nearby property or building. So you must make sure that the construction or the excavation that you're doing does not damage uh, the adjacent building or structure. Okay, then you have the fifth, the shoring, which is the process of transferring a portion of the load of the wall to temporary footings and done when the excavation does not go much below the adjoining footings and when the material is fairly solid. Okay, so this is what you call shoring here. Okay, so it consists of the following members. A, we have the sheet piles, which are timber, steel, or precast planks driven side by side to retain earth and prevent water from seeping into the extraction, and wales, or continuous horizontal beams which tie the sheet piles in place, or soldier piles, which are steel H sections driven vertically into the ground to support, then lagging, or heavy timber planks joined together horizontally to retain the face of an excavation. Then you have cross bracing or rakers, which are diagonals which support the wales, and soldier piles bearing or heel blocks or footings. Then you have the tiebacks, which are secured to rock or soil anchors and resorted to when cross bracing or rakers would interfere with the excavation procedure. Okay, so this is an example of sheet piling. Okay, so we have here, this is the soldier piles or beams, which are steel H sections. And here we have the lagging, which refers to the heavy timber planks joined together side by side to retain the face of an excavation. Then we have here the precast at this side, then the timber, and then the steel. Okay. And here is what you call the tiebacks. Okay. So the sheet piling and soldier beams with lagging, so it would look like this. So the basic principle is you prevent the soil here from eroding to this section. Okay, so this is particularly important, class. If you are excavating a high-rise building on this side, and then there's another building here. Okay, because if you won't do this, the soil here will collapse and along with the building. So it will really be quite dangerous for the people, for the community also. Then it would really, what you call this, you will face litigations. Okay? Then you have the needling and underpinning. Okay, so it's a process where needles or girders are used in cases where part of the weight of the wall has to be carried, as when the old footing is removed and the wall underpinned or carried down to a new footing at a greater depth. Okay, so this is the needle, which is a short beam passed through as a wall or a temporary support while the foundation or part beneath is repaired, altered, or strengthened. Okay, okay, so you're going to insert it here. This is the dead shore, which is an upright timber for supporting a dead load during the structural alteration of the building, especially one of two supports for a needle. Okay, so this is the needle class. You're going to support it here. You're going to place it here, the new foundations. Okay, then you're going to repair this or change to another one. I think in this case, a new foundation, foundation for this structure was made. Okay, so this is the old foundation. Then you have what you call the process of dewatering, which refers to the process of lowering a water table or preventing an excavation from filling with groundwater. So it is accomplished by driving perforated tubes called well points into the ground to collect water from the surrounding area so it can be pumped away. Okay, so this class is our general lecture on uh, site investigation, soil mechanics, and excavation and earthworking. So I encourage you class to read further on other materials related to our lectures. Okay, so don't rely solely on our lecture if you want to really improve and learn something beyond the general scope of our lesson. Okay, so if you have any questions or inquiries, as what I've said before, you can freely send a message to me uh, anytime. Then, because I'll always reply class as long as I'm connected to the internet. Okay, so stay safe and see you next week.